Okay, so start tayo dito sa experiment guide 3. No? So last time, na yun nga, na-message ko na naman sa inyo, I thought kasi yun ay diameter, no? However, nakalagay pala radius. So bale, for the bond length, add nyo lang yung dalawang covalent radius. Okay. So ipag-add nyo lang yung dalawang covalent radius, makukuha nyo yung data from this PowerPoint bandang dulo. Yun lang naman yung medyo kailangan natin i-recheck. Okay. So yun, nasa kabilang screen Ayun. So for the bond length, just add the two covalent radius. No? Sabi ko last time average kasi I was thinking na diameter yon nandito pero radius pala. No? So kunin mo lang yung average nila. Saan kaya yan? Teka lang. Tagal mag-load. Ayun. Pero, ayan. So ito yung mga atomic radii, no? So, yung covalent radii, ipag-add nyo na lang yun. However, if your bond is written here, itong dilaw na table na to, kapag yung bond nyo andito sa nakalista dito, pwedeng ito na yung kunin nyo. Kahit wag nyo na ipag-add ito. Okay. And sabi ko rin kanina sabi ko rin last time sa iba sa inyo, there are differences, 'di ba? Kasi kunwari pag pinag-add ko dito, ba't iba 'yun dito, sir, no? Kasi ang reason diyan ay magkaibang resources kasi to, no? So, etong may yellow na to, this is textbook ni Chang. And this table sa Google lang to kinuha, no? Sa Google lang nila kinuha, no? So, bale, magkakaroon talaga ng differences na and ganun talaga sa chemistry, no? Depending on what material you are using, you will get small differences sa results mo. Okay? Pero the idea is andun pa rin naman, no? So basically the bond length is just the sum of the two covalent radii. Okay? So kapag andito naman yung bond nyo sa table na to, ito na lang gamitin nyo. However, kapag wala, use this table. Okay, so again, bakit may difference? Okay lang ba yun, sir? So, sabihin natin okay na lang, no? Kasi the two materials are from different resources. So, itong table na to, iba yan sa nandito sa table na to. Magkaibang author yung mga gumawa niyan. Yun yung problem namin dito. Okay, so, yan. Hayaan nyo na lang yan, kahit magka-iba. Okay. So anyway, wala namang ganyan sa midterm, no? So you don't have to worry. Only dun lang siya sa worksheet. Okay? Then for electronegativity difference, you are already familiar with this table, ito na yung gagamitin nyo talaga. Okay? So yun lang yung pointers ko for experiment 3 guide. For the bond length, gamitin nyo tong table na to, itong dilaw. However, kapag wala dyan, dun nyo lang gamitin tong table sa taas. Okay? May differences sa values because magkaibang resources yung dalawang table na yan. Okay? So, hayaan na lang natin for now. Okay? So, yun. And then, for experiment 4, ayan, hopefully na-balance nyo na, no? Okay. So, for this part, since hindi gumagana itong link dito, I think they made this worksheet around 20 something pa, no? Mga 2018 pa ata nila to ginawa. Kaya hindi na gumagana yung flash, no? Ngayon kasi hindi na talaga nag-work yung flash, no? So, in order for you to answer this, just look at this table here. 'Di ba may kwento ako about activity series? Teka lang. Okay. So, yan. So, this activity series will tell you kung magre-react ba sila, no? So, kunwari, sabi dito, HCl, yung H lang yung gusto natin pansinin dito. Will HCl react with Ag? So, titignan nyo dito yun sa activity series. Okay. So, kapag sa activity series, ito yung H mo, tapos yung metal mo nasa baba niya, hindi yun magre-react. Okay. So, yung H pati Ag, hindi sila mag-produce ng bubbles. Okay? So, ganun lang siya gamitin. So, again, kapag HCl, will it react with Ag to form gas? Ang sagot natin ay hindi, no? Kasi since yung H ay nasa taas, yung metal nasa baba, hindi sila magkakaroon ng violent reaction. So, walang hydrogen gas na mapo-form. Okay? So, ito naman, for example, copper, calcium pala to. So, calcium, will it react with Ag? HCl. Okay? So, tingin ka uli dito sa inyong table. Okay? So, yung calcium nasa taas ng H. Kapag yung metal nasa taas ng H, dun yun magpo-produce ng gas. Okay? So, again, kapag yung metal nasa baba ng H, hindi yun magpo-produce ng gas. Pero, kapag yung metal nasa taas ng H, dun yun magpo-produce ng gas. Okay? So, ganun gamitin yung table na yan. May question tayo. Sir, di po ba maapektuhan yung ng charge yung bond length? Ideally, wala siyang effect masyado. Kaya covalent ano na yung ginagamit natin. Covalent radius na yung ginagamit natin. Kasi for covalent radius, included na yung charge dun sa factor na yun. No? So just use the covalent radius, then yun yung ipag-add nyo. Hindi na natin masyado i-consider yung other factors, no? Kasi included na sila doon. Ayan. Kasi kapag inisip nyo pa masyado yung mga ganung factors, mas lalo kayong ma-stress, no? To be honest. Okay. Kaya ang gawin nyo na lang, just add the two covalent radius. Okay. Kasi included na yung mga ganung factors sa pag-compute nun. Kino-compute kasi yun yung bond length. Okay. So may equation kami na ginagamit doon para malaman natin yun yung radius ng atom. We use the Bohr equation. Kaya yan. So, included na dun sa equation ni Bohr yung charge. Okay? So, yun lang. So, when po deadline ng experiment 4? Ang submission naman na ginagawa natin, di ba, ano lang tayo yung parang continuous lang tayo. As in, hindi ko kino-close yung submission box because yun nga, just in case na may tanong kayo, you can still edit yung sinubmit nyo. Pero ganito yung mangyayari. Yung last na submission ng ating mga experiment worksheets from chapter 1 to chapter 5, yung pinaka-last na submission yan will be next week. So I can compute for your midterm grades. Okay? So ganun. So okay lang, mag-submit kayo this weekend or next week, basta hanggang next week lang. Kasi yun, magko-compute na ako ng midterm grades nyo na. So para masama ko na yung scores nyo dyan. Okay? So yun. So the submission is continuous. However, final deadline natin for all the experiment guides from 1 to 5 ay next week. Okay? Doon ko sila i-close next week para hindi kayo magahol masyado. Pero it doesn't mean naman na hindi nyo siya gagawin na, no? Gawin nyo pa rin, no? Although, hindi ko na kayo pinapressure sa deadline pagdating sa experiment guides, no? Okay. Kasi I know may mga tanong-tanong kayo dito, kaya sige, entertain ko pa rin kayo doon. Okay? So, yun. For this part naman, yun lang. Just compare the metals here. Okay. Kunwari, tinatanong dito, reactivity of metals. Ang gagawin nyo lang, you just rank these metals. No? I-rank nyo lang sila based on the activity series. Kung sino pinaka nasa taas, sila yung pinaka reactive. Kung sino yung pinaka nasa baba, sila yung least reactive. Okay. So, itong nasa taas, ME lang yan. So, ito yung mga metals na gusto natin i-rank. No? Dito kasi sa link na to, dati gumagana to, no? Before tanggalin yung flash sa buong internet. Lately lang kasi tinanggal yung flash. Okay. So, before gumagana tong link na to, may mga solution doon, tapos paghahaluin mo sila, no? Pero since di na yung gumagana, all we can do na lang is to rank the metals based on the reactivity table. or the activity series. Again, kung sino nasa taas, yun yung highest in terms of reactivity. Kung sino yung nasa baba, yun yung lowest in terms of activity. So, irarank mo lang sila from highest to lowest. Okay? So, again, wala na tayo masyadong may input dito because hindi na gumagana yung link. Okay. So, dead na yan kung na-check nyo. Diba? Plugin is not supported kasi pinatay ng internet yung Flash, Adobe Flash. Hindi na siya gumagana ngayon. Okay. So, yun yung experiment 4. Again, kailan yung ultimate deadline ng lahat ng worksheet? By next week. Okay. So, para ma-checkan ko na. Nag-a-announce na lang ako kung kailan yung last submission. And yun. And for experiment 5, sabihin ko na rin kasi I'm hoping na matapos natin tong chapter 5 para by Friday, hindi na tayo mag-meet para makapag-review kayo. No? Kasi if isagad ko pa sa Friday yung ating discussion, mawawalan na kayo ng time mag-review masyado. No? And I know yung lecture exam nyo is madugo. No? Nakita ko yung lecture exam nyo, 100 items yun compared to the lab na 50 items lang. So, iniisip ko, tapusin natin yung discussion today so that by Friday, you have plenty of time to review for the lecture and the laboratory. No? So, sa lab, madali lang naman Okay. Matataas naman score nyo sa quiz. So, most likely, mas mataas pa score nyo sa midterm. Okay. So, ganun lang. Pero yung lecture, yun yung kinakabahan ako para sa inyo. Kaya mag-aral kayo maigi. 100 items yung lecture niyo. Okay? So for experiment 5 naman, ganito gagawin nyo. So since wala tayong experimental data about this, pwede to gawin sa bahay pero wag na lang muna. No? Kasi hindi ka makakagawa ng 10% sugar, 30% sugar, no? Propanol, no? Wala tayong mga ganitong chemicals sa bahay. Kaya hindi natin matetest yung kanilang viscosity. Yung viscosity, yun yung lapot. No? Di-discuss natin later. So, for this part, leave this blank. Okay? Wala kayong ilalagay dito. Ang sasagutan nyo lang bale ay yung guide questions ulit. So, for the guide questions, just as I told you last time, as much as possible, onting sentences lang, at least 3 to 4, or better kung 2 to 3, So, wag nyo na gawin nobela kasi i-check ko rin naman yan Okay. So, yun. So, provide explanations about these questions. Yun lang. So, again, yung table, wag nyo na i-fill out kasi wala tayong experimental data. However, yung guide questions, ito yung pwede nyo sagutan. Okay? Okay, so yun. So that will be all for all experiments, no? So again, please remind your classmates, no, kung may group chat kayo, that the ultimate deadline for all experiments 1 to 5, no, is by next week, no? So next week na yung last submission niya para ma-checkan ko na so I can give your midterm grades. Okay? So yun lang. For the quizzes pala, so bukas i-open ko na yung quiz 4 nyo. And then yung quiz 5, i-open ko yon by maybe next week, no? Pwede sabay ko siya sa next week. Madali lang naman yung quiz 5. Okay, gas loss lang to pati forces of attraction. So easy lang. Okay, so that's all. Maybe we can start na. No? Okay. So do you have any questions about our activities para isang bagsakan na so that pagdating ng Friday hindi nyo na kailangan mag-worry about the discussion. No? Review na lang kayo. It seems na okay na tayo. No? Okay, so let's start. This will be our last discussion for the midterm period. So medyo mahaba to. Kapit lang kayo. Although madali lang to. Okay. Okay. So our last discussion is about the gases, liquids, and solids. So, what we know about these three, no? So, these three are the primary forms of matter, no? So, sila yung major form ng matter natin. Kasi maraming uri yan, di ba? We have liquid, gas, solids, plasma, Bose-Einstein, condensate, no? But in our daily experience, we encounter gases, liquids, and solids all the time. Okay? Ito yung mga na-experience natin. Huminga ka, gas yun. Uminom kang tubig, liquid yon. Then, solid. For example, itong pencil ko, solid to, no? So, bakit nga ba nag-exist yung matter into many phases? Okay? So, one of the reason why matter exists in many phases, no, is the kinetic theory, kinetic molecular theory of matter. Okay? So, according to this theory, our matter can be described as solids, liquid, and gases depending on its kinetic energy. Okay? Remember, lahat ng bagay sa mundo gawa sa atoms, gawa sa matter, 'di ba? Ibig sabihin nun, kapag yung matter mo gumagalaw, it corresponds to a certain phase of matter. Kunwari, steady lang siya, hindi siya gumagalaw, solid 'yon. Okay? So for example, itong pencil na to, solid to kasi yung matter dito, steady lang siya. Hindi siya gumagalaw. However, once it starts moving, dun siya magiging liquid. For example, itong nasa alcohol ko. Or pwedeng gas na. O, hingahan nyo sarili nyo. Yun. Yung mga particles dun, gumagalaw na. So that is the reason why there are many phases of matter. No? The answer is the kinetic molecular theory. It tells us that we can explain the physical behavior of the matter depending on the kinetic energy of it. No? So there are some postulates here. No? There are some statements, okay, about this theory. Pero ayun nga, sinamarize ko na siya into few sentences lang. No? So yan. Pero basahin pa rin natin. No? So according to kinetic molecular theory, statement 1, yung matter, gawa yan sa tiny particles. Okay? So gawa sila sa tiny particles, which is true. Alam natin na gawa sila sa atoms. And also, those particles may collide, no? They also move in random motion. So ibig sabihin, they possess kinetic energy, no? So kapag yung matter gumagalaw, may energy. Okay. So in the statement 3, one of the reasons why they also move is their charges. No? For example, you have ions in your solution. Sa tubig mo, yung particles gumagalaw dyan because of, let's say, mga charged species dito. Okay? So yung attraction nila that will displace the other molecules around them. Okay? So that's why gumagalaw-galaw yung particles sa liquid. Okay? And also, when you increase the temperature, the kinetic energy increases, no? Okay. So, imagine nyo to as, kunwari, kayo, no? O, kapag kayo naiinitan, paypay kayo ng paypay. So, imagine nyo kayo yung matter. As the temperature increases, your kinetic energy increases as well, no? So, yun. Because kinetic energy is related to temperature or heat energy. So kapag mas mataas yung temperature, mas magalaw yung particles, no? And this is the reason why bakit mas madali matunaw yung, let's say, Milo sa tubig na mainit kaysa sa malamig, no? Kasi sa tubig na mainit, mas mabilis gumalaw yung particle. Hence, mas mabilis hahalo yung Milo particles. Kasi pag malamig na tubig, hindi agad yun, di ba? Hindi agad siya kumakalat sa water. Kasi masyadong mabagal yung particles, kaya nagka-clump sila. However, kapag mainit, mabilis natutunaw yung Milo sa tubig kasi mabilis gumalaw yung particles. No? Mabilis siya mag-spread out. Okay? So another dito is, for example, maalingasaw, mainit, di ba? Tapos may nagluto. Di ba mas mabilis nyo naaamoy siya? Okay? Kasi mas mabilis kumalat yung particles kapag mas mainit. Okay? Compared sa kapag malamig, 'di ba? Hindi nyo agad naaamoy yung smell ng mga objects kasi mabagal gumalaw yung particles. Then lastly, the collision of particles is elastic in nature. Ibig sabihin yan, the momentum is conserved, no? Physics na to masyado. Pero ang idea lang dito is that pag nagbungguan yung particles, the energy ay transferred. Okay? So, completely transferred yung energy. So, it follows the law of conservation of mass and the law of conservation of momentum. Okay. So, all these 5 statements, ang sinasabi lang dyan is yung matter, gawa siya sa small particles called the atoms. And our atoms possesses both kinetic and potential energy. Okay. So, as you increase the temperature, the kinetic energy of matter increases, no? And as the matter moves more, that means it assumes different phases. One example would be pag pinakuluan nyo yung tubig. Okay? So, ano nangyari pag pinakuluan nyo yung tubig? It converts from liquid form into gas. Bakit? Kasi, the only difference between the two is, ano lang, yung energy ng particles natin. Okay? So, for example, kunwari ice cube to liquid to gas, pag ininit mo yung inyong matter, what happens is yung ating particles, they are more energetic na. And since they are now more energetic, that means yung ating particle mas magiging magalaw. The more magalaw yung particles natin, the more distant they will be. Mas lalo silang lalayo sa isa't isa. And as they distance themselves, no, from each other, nagko-convert siya into different phase, no. Kunwari, kumpul-kumpul sila, solid sila. Imagine nyo kayong friends, mag-ano kayo, group hug, solid yon. However, pag lumayo kayo onte, you assume the liquid phase. Then, pag lumayo kayo ng sobrang layo, you assume the gaseous phase. No? Ganun din sa matter natin. So, paano natin napaghihiwalay yung particles ulit? You can just add energy, no, in the form of heat. Kaya taasan mo lang yung temperature. That's why yung ating tubig or ating yelo, nagko-convert siya from solid to liquid, then liquid to gas kapag ininit, no? Kasi the heat, no, from the, let's say, apoy, the heat from the fire gives our particles the energy for them to separate out. Okay? So, yun lang yung reason kung bakit may tatlong phases tayo ng matter. And yun yung sinasabi ng kinetic molecular theory. Okay? So, yun lang. Yan. So, that's all. So, ngayon, focus na tayo on the 3 phases of matter. Unahin natin yung gas, no? Because yung gases natin, they can be described by different laws, no? They can be quantified by different equations. So, what is a gas? So, a gas is a form of matter in which ito yung characteristic niya. In terms of volume and shape, it doesn't have a defined volume and shape as it assumes the container shape, no? So, ibig sabihin yung gas natin, yung volume niya pati shape niya, that's variable, no? Parang naikifit lang siya kung saan mo siya ilagay compared to liquids and solids, no? Yung solid, definite yung kanyang volume and shape. Yung liquid, definite yung kanyang volume. Yung shape ay random. But for gases, indefinite yung dalawang yan. Because yung gas particles natin, kung saan mo sila ilagay, okay lang sila. No? They will assume the entire capacity of the container. No? Okay, so yun lang ginagawa nila. Also, in terms of density, gaseous phases are low in density. Okay? So, bakit low in density sila? Kasi remember, yung distance ng particle dito ay malalaki compared to solids and liquids, no? Since malalaki yung distance nila, ibig sabihin, they will occupy greater volume, okay? And greater volume means lower density, no? If you could recall the density formula, D equals M over V, no? So, inverse yung relationship ng density and volume. That's why for gases, mataas yung volume, mababa yung density. Okay? That is in contrast with solids and liquids, no? Kasi defined yung volume nila. So, ibig sabihin, mas mataas yung kanilang density. In terms of compressibility, solids and liquids are virtually uncompressible. Okay? However, for gases, they can be compressed. No? Yung mga malalayong particles, pag pinagdikit mo, pwede. No? One example is itong upuan ko na to. Pag pinindot ko to, ayun, na-compress yung gases sa ilalim ko. Okay? So, ganun. So, ginagamit yan sa mga upuan, office chair like this. Kaya sa sasakyan din, sa gulong, mapapansin nyo doon, kapag flat yung gulong, dadagdagan mo lang siya ng gas particles, mapupuno na uli yung hindi na uli flat yung gulong, no? Because yung gas particles doon, kinocompress mo so that hindi flat yung tire. Okay? And also, in terms of thermal expansion, yung ating gas phases, mas mataas yung kanyang thermal expansion compared to solids and liquids. No? Kasi yung particles natin, nag-expand sila habang umiinit. No? For gaseous state, mas malakas yung expansion ng gas kapag mas mainit. That's why na-form yung ating mga bagyo. No? So yung rapid expansion ng gases in the air, that causes turbulence, no? And then later on, maging LPA na yon. Okay? So, ganun. However, for solids and liquids, their expansion isn't that observed, no? Hindi ganun ka-observe. Okay? So, yun yung properties ng gases natin. Okay? And maraming molecules sa paligid na gaseous yung phase. Okay? So, ngayon naman, let's talk about how we classify gases. No? Paano natin sila nakakarakterize? Paano natin sila nape-predict yung kanilang behavior? Okay? So, in predicting the behavior of gases, we use some equations, okay, na tinatawag nating gas laws. Okay? So, the first gas law is the Boyle's law. This is the pressure-volume relationship of the gas. No? So, according to Boyle's law, the pressure and the volume of the gas is inversely proportional. Ibig sabihin, kapag mataas yung pressure, mababa yung volume. Or kapag mababa yung volume, kapag mataas yung volume, mababa yung pressure. Okay? So, yun yung idea ni Boyle's. No? One example is itong upuan ko. Okay. So, kapag binaba ko tong canister sa ilalim ko, ayun, bumaba ako, yung volume ng gas ko dito ay lumiit. However, the pressure of the gas increased. No? Lumaki yung pressure ng gas doon sa loob. Okay? But if I expand my canister dito, okay, so yan, umakyat uli ako. Pag in-expand ko yung upuan ko pataas, that means the pressure inside the canister below is low. No? Okay? So yan. So ito, ang ating Boyle's law, for any state of gases, for initial and the final state, the pressure is inversely proportional to the volume. Okay? So at initial state, pressure is inversely proportional to the volume. That's equal to a constant. At the final state, that is also the same. No? So the pressure and the volume are still also proportional to the constant. Since parehas silang equal sa constant, then we can equate them together to form this equation. Okay? So we have P1 V1 equals P2 V2. So ano lang sinasabi dito? That yung pag may nag-multiply mo tong dalawa, they are equal to a constant. Yung constant sa initial state and the final state ay the same. That's why this is equal to this. Okay? So the pressure volume of the first state is equal to the pressure volume of the final state. Okay? So, ganun. So, ano yung mga examples nito in daily life? Bukod dito sa upuan ko. One example would be breathing. No? So, pag humihinga kayo, what happens is that the pressure of your chest, no? Yung chest cavity natin, may pressure doon because of the diaphragm's movement. Okay? Pag yung ating diaphragm, nag-expand yan, the pressure inside the chest cavity decreases. Ibig sabihin, pag tumaas yung volume ng ating chest cavity, yung pressure sa ating lungs ay bumababa. That's why we inhale the gases around us. So, yun yung isang example ng Boyle's law. When your diaphragm expands, yun lang naman yung bumababa pa ilalim. So that means tumaas yung volume. And because yung volume tumaas, bababa yung pressure ng ating chest cavity. That's why we inhale the gases. However, if we want to exhale, ang gagawin ng ating diaphragm is that aakyat siya. So, ibig sabihin nun, bababa yung volume ng ating diaphragm, ng chest cavity, kasi umangat yung diaphragm eh. So, as a result, mabubuga natin yung air na nasa loob natin. Okay? So, since constant yon, so since yung pressure volume ay constant, pag pinag-multiply natin, doon natin makikita that yung ating breathing state ay parang constant lang. No? Constant siya at any time. No? So, hindi ka pagod pag humihinga because pag pinag-multiply mo yung pressure and volume mo, they are the same all throughout. No? So, yung body natin ay nasa equilibrium state. Ibig sabihin, nasa balance tayo. That's why di nakakapagod huminga. Kaya tuloy-tuloy lang tayo sa paghinga. Okay? So, yan. So, yan. So, that's one of the many examples ng Boyle's law. So, ngayon, let's go to the other law, the Charles law. So, according to Charles law, ano meron dito? According to Charles law, the volume and the temperature of the gas is proportional. Okay? So, sabi niya, volume is proportional to the temperature. Ibig sabihin niya, pag tumaas yung volume, tataas yung temperature. Di ba? Parang si Elsa lang, may araw pataas. Okay? Pag tumaas yung volume, tataas yung temperature. So, ano example niyan? For example, ngayon sa mga bagyo, no? Because of the increasing temperature in the atmosphere, yung ating gases doon nag-expand. So, sila ay umiikot-ikot, no? To form the storm. Okay? Another example then is yung, kunwari, yung lata, inapoyan mo, what will happen? The can will explode. Okay? Sasabog yung lata. Okay? So, bakit? Kasi nga, ano nangyayari? Kapag tinasa mo yung temperature kasi, what happens is that your particle becomes more energetic. And as your particles become more energetic, they push the container. Tinutulak nila yung container. Kaya minsan sumasabog yun. Okay? Because they want bigger volumes. Okay? So, another example of this is yung lata uli. For example, yung mga deodorant, Lysol, no? No, kaya yung Glade. Di ba pag pinindot yun, lumalamig yung bote? Okay? So, I actually have one here. Kunin ko lang. Okay. So, ito may Glade ako dito. So, normal lang yung temperature niya. However, pag pinindot ko to, lumalamig yung bote. Tapos bumabango yung paligid. Bakit lumalamig yung bote? Because of the Charles law. Ang nangyayari kasi kapag pinindot natin to, yung volume ng gases dito bumababa. As a result, yung temperature bumababa din. Okay? So that's Charles' law. It states that the volume and the temperature is directly proportional. Okay? So as you increase the temperature, the volume increases. That's why yung ating mga lata, sumasabog sila. Okay? And kapag binabaan mo naman yung volume, ay binaba mo yung temperature, bababa yung volume. Okay? One example is, kunwari, maglagay kayo ng plastic na may hangin, or let's say balloon, lagay nyo sa ref. Lumiliit yung, hindi yung ref yung lumiliit yung balloon, di ba? So, the reason why is, ganito. Di ba kapag tumataas yung energy, nag-expand yung gases. Pag tumataas yung heat, nag-expand sila. However, pag pinalamig mo naman sila, bumabagal sila. So, as a result, since mabagal na yung mga particles natin, hindi na siya mag-expand. Magko-contract sila. Okay? So, kumbaga parang giniginaw din yung particles kapag malamig. So, that's why the volume decreases. Okay? So, yan. So, this is the proportionality. Okay? So, if we're going to make it equality, if gagawin natin yung equal sign, we have to introduce the constant. V is equals to KT. So expressing this in terms of K, we get V over T. So the constant at the initial state is the same as the constant at the final state, no? So, ibig sabihin, kung ano yung initial state ng system mo, at sa final state, yung constant doon ay parehas lang. Kaya nga sinabing constant, no? So that means volume over temperature 1 initially is equal to volume over temperature 2 at final condition. Okay. So yan. So that's Charles' law. So ito, pwede nyo ito gawin sa bahay. For example, may bote kayo na may hangin lang. Initin nyo yung container ng bote. Mag-expand yung balloon. Okay. So yan. And another example would be the Gay-Lussac law. Okay, so Gay-Lussac law. So according to Gay-Lussac naman, the pressure is directly proportional to temperature. Okay, so that means when you increase the temperature, the pressure will increase. No? So yun yung sabi niya, pressure is directly proportional to temperature. Increasing the pressure increases the temperature. Decreasing the pressure decreases the temperature. So, nag-a-apply din yun sa ating logic dito sa Glade. Pag pinindot ko to, bababa yung volume and at the same time, bababa yung pressure sa lata. Okay. So, since bumaba yung pressure dito sa can, the temperature will decrease as well. Okay? So, ganun. Ano pa example niyan? Kunwari, you have a pressure cooker. So, it follows the Gay-Lussac law. Okay. So, ano nangyari kapag tinaasan mo yung temperature ng pressure cooker? Tumataas yung pressure dyan. Di ba? Tumutunog yung taas, no? Umaakit yung takip niyan. Okay. Bakit? Kasi, pag tinaasan mo yung temperature, yung ating particles sa loob, they push around the container. And since they push the container more, that means mas mataas na yung pressure niya sa loob. Okay. So, ganun lang. And lastly, we have Avogadro's law. Okay. So for Avogadro's equation naman, by the way, hindi ko pa pala na Ay, ito yung sabi ni Gay-Lussac, di ba? That pressure is directly proportional to temperature. Gawin natin tong equality by introducing a constant. Expressing the constant, we will get P over T. At initial state, P1 over T1 is equal to constant. At final state, P2 over T2 is equal to constant. So since parehas lang na constant yon, that means P1 over T1 is equal to P2 over T2. So this is the equation for Gay-Lussac law. And lastly, we have the Avogadro's law. According to Avogadro's law, when you increase the amounts of gases or the moles of gases, tumataas din yung kanyang volume. So that means volume is directly proportional to the number of moles of gases. Totoo ba yan? Totoo yan. Example is yung lobo. Pag hinipan nyo yung lobo, what happens? Pag hinipan nyo yung lobo, nag-expand yung balloon. Okay. Bakit? Kasi dinadamihan mo yung gas particles sa loob. Yung CO2 nyo, pupunta siya sa loob ng balloons. So that's why, according to Avogadro, increasing the number of moles of gases increases the volume. Okay? So that means volume is directly proportional to the number of moles of gases. Itong proportionality, gawin natin equality by introducing a constant. And then we express the equation in terms of constant. We get volume over moles equal constant. At initial state, volume 1 over N1 is equal to K. And at final state, volume 2 over N2 is equal to the same constant, K. So since parehas silang equal to the K, we get V1 over N1 equals V2 over N2. Okay. So ibig sabihin, yung ratio ng volume and moles ay equal all throughout. Okay? So yan. So ito yung example. Kunwari, you have a canister, nilagyan mo ng gases. Okay. So yan. Pag marami kang moles, tataas yung volume. Pag konti yung moles mo, bababa yung volume. Okay? And yung tatlong equations na na-discuss natin, pwede natin sila i-combine, yung Boyle's law, yung Charles law, and yung Gay-Lussac law. Pwede natin sila i-combine to get the combined gas laws. So in the combined gas laws, yung pressure, volume, and temperature, pinagsama-sama natin. Okay. Remember kanina, we have PV equals K, kaya P1V1 equals P2V2. Okay. We also have equation na P1 over T1, P2 over T2. And we also have equation na V1 over T1, V2 over T2. Okay? So basically, pag pinagsama-sama natin yung Boyle's law, Charles law, pati yung Gay-Lussac law, okay, we will get this combined gas law. So it states that the pressure, volume, and the temperature, okay, pressure times volume divided by temperature is the same as to the final state now. Okay. They are directly proportional with each other. Okay. And also, if we include the Avogadro's law, makukuha naman natin yung ideal gas law. Okay. So sa ideal gas law, we have the relationships of pressure, volume, moles, and temperature. So ito na yung pinaka-final form ng ating gas law. Okay. So kumbaga, pinagsama-sama na dito yung Boyle's, Charles, Gay-Lussac, pati yung Avogadro's law. So by including the moles of the gases. Okay? And this equation may constant pa rin to in the form of R. And the R can be experimentally determined as 0.08206 or 0.0821 liter atmosphere per mole Kelvin. Okay? So that's the ideal equation. Okay? So skip muna tayo sa PowerPoint. I-apply natin yung mga equations na yon sa calculation para may ma-practicean kayo. Okay, so again, ano yung mga nakwentuhan na natin? So, ang nakwentuhan na natin ay ang mga sumusunod. Okay. So, napag-usapan natin si Boyle. Sabi ni Boyle, P1V1 equals P2V2. Yan si Boyle. Okay. So, sabi niya that pressure is directly proportional, inversely proportional to the volume. Pressure inversely proportional to the volume. Pag nasa numerator yung isa, nasa denominator yung isa, inverse yun. Okay? So, they are inversely proportional. Ibig sabihin, pag tumaas yung pressure, bababa yung volume. Pag tumaas yung volume, bababa yung pressure. So, ano pa yung mga gas laws natin? We have Charles law. So, ano si Charles law? V1 over T1 equals V2 over T2. Okay? Nandito ba? Oh, ito pala. So, yan. So, according to Charles law, we have the volume directly proportional with the temperature. Okay? So, that means pag tumaas yung volume, tataas yung temperature. Pag bumaba yung volume, bababa yung temperature usually. Okay? So, that's the Charles law. Or in equation, that's V1 over T1 equals V2 over T2. Then we have the Gay-Lussac law. The pressure is directly proportional to temperature. So, increasing the temperature increases the pressure. Okay? So, we get the final equation P1 over T1 equals P2 over T2. Sa Avogadro's law, sabi naman dito, ang ating volume ay directly proportional with the moles of the gases. So, increasing the mole of gas increases the volume. So, imagine nyo yung balloon. No? Hipan nyo yon, lalaki yung volume niya. And then, finally, pag pinagsama-sama natin lahat ng gas laws, we get the ideal equation. This time, yung proportionality constant, may number na siya. Yun na yung gas constant. R is equal to 0.08206 LATM per mole Kelvin. Mali yung units ko dyan, na-typo ako dyan. Okay. So, that's the gas constant. Yung sinasabi natin kanina na constant, ito na yon, may value na siya nung pinagsama-sama natin lahat ng equations. Okay. There are also conditions about this. No? Pag sinabi nating STP, STP meaning non-standard temperature and pressure. When we say STP for gases, the temperature is 0 degrees Celsius and the pressure is 1 atm. Okay? Okay, so yan. So again, pag sinabi nating STP, tawag doon ay standard temperature and pressure. It means that the temperature is 0 degrees Celsius and the pressure is 1 atm. Pero ito magtataka kayo, no? Kunwari, plinag-in ko yung temperature na 0 dito. Possible ba yon? Hindi, no? Kasi kapag plinag-in ko yung 0 dito, magiging 0 lahat to. So that's why we don't use the Celsius scale dito. We do not use the Celsius temperature in the gas laws, in any gas laws. Be it Charles law, Gay-Lussac law, combined gas law, and the ideal gas equation. Hindi natin ginagamit yung temperature in Celsius scale, neither yung Fahrenheit scale. Ang ginagamit natin ay yung Kelvin scale, no? Because yung Kelvin, it is always positive, no? And isa lang yung zero niya, yung absolute zero. Okay. Kasi kapag yung Celsius nilagay mo dito, mas zero lahat yan. Zero din yung score mo, no? Kaya we use Kelvin. If you could still recall, to convert Celsius to Kelvin, all you have to do is to add 273.15 sa degrees Celsius mo. Pag-add mo lang sila, you will get the Kelvin value. Okay? So with all those examples, with all those equation, sagot tayo ng onting examples na. Kasi yung exam nyo, onti lang naman yung gas loss doon. Okay. Kaya ontian na lang din, dalian na natin. Okay. So kaya nyo naman eh. So number 1. If 22.5 liters of nitrogen at 748 millimeter mercury are compressed to 725 millimeter mercury at constant temperature, what is the new volume? What is mmHg? No, mmHg is a pressure unit. No? So pressure unit yan. Okay, so yan ay pressure unit. Marami kasing pressure unit eh. We have the ATM, the standard. We have the pascals. We have the mmHg. And the torr. So yan yung mga pressure units natin. Ang standard na ginagamit sa gas laws ay ATM. Okay, especially kapag ideal gas equation yan. Although pwede rin gamitin yung iba. Okay? So mamaya pakita ko sa inyo yung conversions nila. Okay? Just kasi mamaya may problem tayo na kailangan natin mag-convert. Okay? So for now, yan, we know that mmHg is a pressure unit na millimeter mercury yan. Okay. So sagutan natin to. May initial volume tayo ng gas. Sabi dyan 22.5. Yan yung initial volume ng gas. At ito yung initial pressure. Ang final state natin, may kita mo yon sa keyword na 2. Ibig sabihin nun, going to the final state. The final pressure is this. Hinahanap ang final volume. So ano yung mga given natin? We have the pressure and the volume. That's why we have to use the Boyle's law. Okay? So according to Boyle's law, P1 B1 equals P2 V2. So lista natin ano yung pressure 1. O yun yung mga sinabi sa first statement. Ay, volume 1 pala yan, sorry. So this will be the initial volume, the initial pressure. And pag nakita nyo yung keyword na 2, it means final state na yung mga nasa right side nun. Yun yung mga keyword natin. 2, ibig sabihin, ito ay pressure 2 na at hinahanap na yung volume 2. Okay? So beware of the keyword 2. Okay? Ibig sabihin nun, second, ano na tayo, or the final state na tayo ng matter. Okay? So with all those info, hanapin natin yung V2. So we have this equation here. Kunin natin yung V2. Mapapansin nyo yung V2 may katabi na P2. So para matanggal yung P2, we divide it sa both sides ng equation. So we will get V2 equals P1 V1 over P2. Diba? So let's plug in the values. Okay, so ano yung pressure 1? 748 mmHg. Initial volume is 22.5. And then the final pressure is 725. Diba sabi ko sa inyo kanina that the standard pressure unit is atmosphere. However, ito yung however natin, if the units will cancel out, kahit wag mo na i-convert. Okay? So, pag nakita nyo sa equation, magka-cancel out din naman yung mmHg. Wag nyo na i-convert. Sayang yung effort. Okay? So, as you can see here, millimeter mercury will cancel out then. Okay? So, there is no need to convert the pressure. Okay? So, yun lang. Baka kasi mamaya isipin nyo, kailangan ko i-convert lahat into ATM. Not necessarily. Okay? So, ganun lang. Hindi always. Kasi, pag nag-cancel out, wala din. Sayang din effort mo. So, what will be the final volume? So, the final volume is 23.21 liters. So, that is the final volume of the gas. Does it make sense? No? Does it? No? It does. No? Kasi ano nangyari? Bumaba yung pressure. So, according to Boyle's law, the volume must increase. No? Because the relationship of the two ay inverse. No? Ibig sabihin, pag tataas yung isa, bababa yung isang variable. Bumaba yung pressure. So, that means dapat tumaas yung volume. Okay? So, ganun lang. Easy lang, di ba? So, alam ko naman, umay na kayo dito nung senior high school. Kaya, review na lang ginagawa natin. Okay? So, that will be one example. Let's have this one, number 9. So, for number 9, the gases in a hairspray can are at the temperature of 27 degrees Celsius and the pressure of 30 pounds per square inch. Familiar kayo dapat dito sa LBS/IN square. That's pounds per square inch. Ang isang abbreviation yan ay PSI. Okay? So, nakikita nyo yan sa water tank. Kung meron sa paligid nyo na water tank, di ba may gauge doon? Nakalagay doon PSI, meaning nun ay pounds per square inch. Okay? So, yan. So, LBS/IN square, yan ay pounds per square inch. Okay? So, again, basahin ko ulit. The gases in a hairspray can are at a temperature of 27 degrees Celsius and a pressure of 30 pounds per square inch. If the gases can reach a pressure of 90 pounds per square inch, the can will explode. To what temperature must the gases be raised in order for the can to explode? Okay. So, ano sabi dito? Ang initial state natin ay yung temperature ay 27 degrees and ang pressure ay 30 pounds per square inch. But, if you can manage daw to increase the pressure to 90 pounds per square inch, ibig sabihin yun na yung final state natin. Ano kaya yung final temperature mo rin? So, what will be the final temperature? Okay? So, ang sabi dyan, again, ang initial temp mo, 27, initial pressure, 30. Pag i-increase ko yung pressure sa 90, ano yung corresponding temperature? Okay? So, anong equation kailangan natin dito? The equation needed is P1 over T1 equals P2 over T2. Gay-Lussac equation. Okay? So, yan. So, let us solve for T2. Ito yung hinahanap si T2. Okay. So, in solving for T2, we have to do some algebra, no? So, kailangan natin i-cross-multiply muna to. So, let us cross-multiply the denominators. So we have P1, T2 equals P2, T1. And then since we are just looking for T2, yung T2 lang yung gusto natin, we divide both sides by P1. So our final equation would be P2 T1 divided by P1. Yan ay equal sa T2. Okay, so again, pag ganito yung uri ng equation nyo, kunwari, parehas silang may fraction doon, you cross-multiply them. Then yung hinahanap mo, yun lang itabi mo sa isang side, i-divide mo yung katabi niya sa both sides. For example, yung P1 yung katabi ng T2. O, dinivide ko siya sa both sides para T2 na lang yung matira sa left. Okay? So, I have this equation here. O, what's next? Plug in na lang. So, plug in. P2, final pressure is 90 psi, 90 pounds per square inch. T1 is 27 degrees Celsius. But, kailangan ba 27 degrees Celsius ilagay ko dito? Ang sagot ay hindi. Because again, as I told you kanina, basta gas law, do not use Celsius scale. Always use the Kelvin. Okay. Bakit? The problem kasi with Celsius is may zero siya. Okay. Kaya ayaw natin mag-Celsius scale dito. Okay. So instead of using Celsius, we use Kelvin. So that means we have to convert 27 degrees Celsius to Kelvin. So that's 273.15 plus the Celsius value. So we get Kelvin equals 300.15. So we get 300.15 Kelvin. O, divide natin yan sa initial pressure. According to the problem, that's 30 pounds per square inch. Okay, so solve natin yan. 90 times 300.15 divided by 30. So that's equal to 900.45 Kelvin. Laki na. Kelvin kasi. Ano yung corresponding temperature niyan sa Celsius? Okay. From Kelvin to Celsius, magsusubtract ka ng 273.15. Okay. So that will be Kelvin minus 273.15. That's 900.45 Kelvin. Burahin na natin yung Kelvin. Minus 273.15. Makuha na natin yung degrees Celsius. Minus 273.15. So the final pressure should be 627 pala. 627.3 degrees Celsius. Okay. So ibig sabihin, yung ating mga lata, they are designed to handle high temperatures para hindi sumabog. But it doesn't mean na kailangan mo to apoyan, no? Nakalagay na nga dito sa bote mismo. May kita kayong apoy na may red na triangle, red na diamond. That means, wag mo apoyan. Okay. Although it will explode at 600 degrees Celsius, it doesn't mean na kailangan mo siya apoyan. Sasabog yan, delikado. Okay? Mamaya masunog pa. Okay. So, kuha pa tayo ng ilang problems. If you want a copy of this, pwede naman ko kayo bigyan. No? Kayo, mag-practice na lang kayo dito. No? Pwede naman. Okay. So, send ko na lang tong copy ng lecture guide ko sa after this class. No? Okay. Ito yung ginagamit namin sa senior high dati. So let's answer this. No? A small bubble rises from the bottom of a lake where the temperature and pressure are 8 degrees Celsius and 6.4 atmosphere. Okay? So, kapag nasa ilalim ka ng lake, ganyang kataas yung pressure. That's why, di ba, kapag nagda-diving tayo, Ang sikip sa dibdib, di ba? Okay. Actually, kahit di ka mag-dive, lumubog ka lang sa tubig, parang iniipit na lungs mo. Okay. Kasi mataas yung pressure doon. Okay. So, nangyari daw dyan, yung small bubble from the bottom of the lake umakyat to the surface, no? Where the final temperature is 25 and the pressure is 1 atm. Calculate the volume of the bubble if the initial volume was 2.1 ml. Okay? So, ano idea dito? So, ito yung lake. Ito yung 2.1 ml na bubble. Okay? Kunwari, huminga si mermaid, no? Tapos, ano mangyari dyan sa bubble na yan? Naakyat yan. Ano kaya yung magiging volume niya pag akyat? Okay? Given yung temperature dito ay 8 degrees Celsius, 6.4 atm. Sa taas ay 1 atm, that's 25 degrees Celsius. Possible ba to? Okay, so possible malaman to because we have variables for pressure, temperature, and the volume. Okay, so since yung tatlong parameters kailangan natin, we are going to use the combined gas equation. Okay, so ano yung combined gas equation? Yun yung P1 V1 over T1 equals P2 V2 over T2. Okay, so yun yung gagamitin natin. Again, kapag tatlong parameters na yung nagbabago, we have to use the combined gas law. Okay, so let's write the combined gas law. Yeah, P1 B1 over T1 equals P2 V2 over T2. Okay, labelan natin yung mga given. Yung 8 degrees Celsius, that is temperature 1. Pressure 1 is 6.4 atm and the volume 1 is, according to the problem, 2.1 ml. Final temperature is 25 degrees Celsius. Final pressure is 1 atm and yung final volume, hindi natin alam. So that means missing si V2. Okay. So since missing yan, we cross multiply the terms. So we will get the equation for V2. That is V2 equals P1 B1 over times T2 over P2 T1. Okay. So with that, let's plug in all our info, but yung temperature, convert muna natin. Kasi sabi ko yung Celsius, hindi pwede yan. Kailangan na Kelvin yan. So, 8 degrees Celsius is, ilan yan in terms of Kelvin? It's 273.15 plus 8. That will be 281.15. And yung 25 degrees Celsius, 273.15, that will be 298.15. Okay? So, yan. Ito yung gagamitin nating temperatures. Again, bawal yung Celsius. Pag ginamit nyo Celsius, mali agad kayo na. Okay? So, let's solve. Sulat ko na nandito. P2 is equals to pressure 1, 6.4 atm. Volume 1, 2.1 ml. Temperature 2, 298.15 Kelvin. Pressure 2, yun ay 1 atm. Temperature 1 is 281.15 Kelvin. So the final volume of the bubble rising from the bottom of the lake to the surface is pakipindot na lang ha. 281.15, 6.4, 2.1, 298.15, 1, 281. Okay. So the final volume is 14.25 ml. Ano nangyari sa volume? Lumaki, no? So lumaki siya pagdating sa surface. So totoo yung mga nakikita nyo sa movies, 'di ba? Sa Titanic, ano pa ba yung mga may tubig-tubig? Yun, sa Titanic, yung sa mga horror, no? Yung, di ba, maliit na bubble, pagdating sa taas, malaki na siya. Okay. Because that is governed by the combined gas law. Okay. So again, kanina ko pa ina-emphasize yung temperature, please i-convert sa Kelvin. So if you did not convert that into Kelvin, mali yung makukuha nyong answer. Let's answer some more problems. No? Para pag natapos tayo dito, pwede sagutan nyo na yung mga questions dito. And this is 1 to 22 naman, so marami kayong pwedeng sagutan. Okay. So mag-enjoy kayo doon. Okay. Last one. Let's answer 19. Last one na to. So number 19, calculate the volume in liters occupied by 5.58 grams of ammonia at STP. Paano kaya to? Okay. So paano to? Dali lang. Okay. So once given sa inyo yung amount ng gas, pag given na yung mass ng gas, gagamitin nyo na yung ideal gas law. Okay? So ano yung ideal gas law? PV equals nRT. Okay. So let's look at this equation. PV nRT, kailangan alam mo yung pressure, alam mo yung volume, alam mo yung moles, alam mo yung temperature, and yung R is constant. We already know that. Okay. So, anong info na meron tayo sa problem? We are given the mass of ammonia. Pero, sa ating equation, ang gusto niya ay moles. Ang given sa atin ay mass. Paano yon? So we can convert mass into moles using mass-mole relationship sa stoichiometry, di ba? So we can use the triangle, mass, molar mass, mole. So kung gusto mo makuha, ay, mali pala. Sa taas pala yung mass, mole, molar mass. Okay. So kung gusto mo makuha yung moles ng matter, that is just mass divided by the molar mass, no? Bakit kailangan kukunin yung mole? Kasi sabi sa ideal gas equation, N. Pag N, moles yon. Okay? So kailangan ko ng moles. So that's why in order for me to get the moles of ammonia, I have to divide the mass by its molar mass. Okay? So yan. So dito natin makukuha yung moles dito. Okay? Moles can be calculated. Okay, so check na tayo dyan. So hinahanap yung volume, yung gas constant, kabisado na natin yan. Okay? How about the pressure and temperature? Alam ba natin sila? Yes. Sabi kasi STP. Ano uli meaning ng STP? Standard temperature and pressure. Okay? So standard temperature is 0 degrees Celsius or 273.15 Kelvin. And the standard pressure is 1 atm. Okay, so we already know temperature and pressure. So since we have one unknown variable, we can solve for this problem. Okay. So ganun ha, minsan hindi obvious yung given, especially kapag sinabi STP lang. Okay. Pag sinabing STP lang, yan, kakalculate ka pa. Hindi pala calculate. Alamin mo kung ano lang meaning ng STP. Sabi sa STP, temperature is 0 degrees, pressure is 1 atm. Yung degrees Celsius, i-convert to Kelvin as always. No? So, ganun lang. So, from our ideal gas equation, PV equals nRT. Let's solve for V, that is nRT over P. However, yung moles, hindi pa natin nakukuha. Meron lang tayo mass, hindi mo pwede i-plug in yun doon. Ano gagawin natin? We know that moles is mass over molar mass. Pwede natin i-incorporate yun sa equation. Okay? So that we can write it as mass over molar mass. Okay? So, yan. So, ano ginawa natin dito? Yung moles, in-expand ko as mass over molar mass. Sinama ko na. Okay? Para isang pindot na lang to sa calculator. Okay? So, with this equation, we can now solve for the volume of the ammonia at standard temperature and pressure. Kunin natin yung moles ng ammonia. Okay, wala akong copy ng periodic table eh. Ayan, so 17,031. Okay, so save natin yan. So yun yung molar mass ng ammonia. 17,031 Gmol, grams per mole. Pressure, 180 m. Yung mass, 5.58 grams. R, 0.08206 liter atmosphere per mole Kelvin. And temperature is 273.15 Kelvin. Okay? Pakikabisado yung R ha. 0.08206 LATM per mole Kelvin. Okay, so let's check if our units will cancel. Yung grams magka-cancel, yung moles magka-cancel, ATM will cancel, Kelvin will cancel, the final unit is liter. So that means our equation is correct. Okay, tama yung ating equation. Kasi ang naging final unit ay liters. Paki-plug in na lang sa calcu nyo. Okay, so the volume of ammonia is 7.34 liters. Laki niya, no? Para siyang isang, ano ba yung mga 10 liters? Parang kasing laki yan ng 10 pitchel. Okay, 5 grams ng ammonia lang yung nandun. Diba? Imagine, no? Ganun kalaki yung volume na ino-occupy ng gases. That's why we said kanina that yung gases, sila may pinakamababang density. O imagine nyo sa 10 pitchel, 5 grams lang ng ammonia meron doon. Diba? So, ganun ka, laki yung volume na inoccupy nila. So, their density is very low. Okay? So, yan. So, those are our calculations. I will give a copy of this lecture guide para makapag-practice kayo. Answer nyo na lang itong nasa pages 3 to 6, no? However, yung ibang items dito, wag nyo nasagutan. Okay? Kasi, hindi naman sila covered sa discussion talaga natin. Okay? And sa senior high ko pa kasi ito, kaya, yan, as is yung gamit ko dito. Okay, so you can try to answer other items. 22 items yan. Nasagutan na natin ay 4 ata. 1, 2, 3, 4. Okay, so 4 na yung nasagutan natin. So hopefully, na-cover naman natin lahat, no? So dito yung gas, Boyle's law. Ito yung pressure, volume. Ayan, so okay na yan lahat, no? So ayan. So ganun lang kadali yung magiging questions dito about sa quiz and sa midterm exam. So I assure you that na. Okay? So with that, let's go to our PowerPoint again. Okay? So let's now talk about Dalton's law of partial pressure. Okay? So according to Dalton's law of partial pressure, it states that when we have mixture of gases, the total pressure of the gas is the sum of all the partial pressures of each gases. Ibig sabihin nun, kapag halo-halo na yung gases, may kanya-kanya silang ambag sa pressure. One example would be the atmospheric pressure. Itong nasa paligid natin. The atmospheric pressure is composed of lots of gases. May nitrogen gas, may oxygen gas, may argon, merong pabango natin, yung hininga natin, may ambag din yan sa paligid, no? So, all those factors, no? Sila yung pag pinag-add mo yung mga pressures nila, they are equal to the total pressure. In our case, 1 atmosphere, no? So, yung 1 atmosphere na yon, that is subdivided into nitrogen gas, which is 0.78 at that. Oxygen gas, which is 0.21. And then yung the rest, yung 0.01 atmosphere, that is divided into other traces of gases such as argon, CO2, okay, and etc. Okay, so yun lang yung idea ni Dalton dito, that when you mix gases, their partial pressures adds up to get the total pressure. In equation, that's P total equals PA plus PB plus PC, so on and so forth. Okay? So yan. So this is one example. Kunwari, we have this gas mixture, this gas mixture, this gas mixture. Pag pinaghalo-halo natin yan, the total pressure will be the sum of all the partial pressures. No? So yun lang yung kwento ni Dalton. So ito nga. So ito, air is made of 79% nitrogen. Actually, this is 78, no? Then oxygen is 21, then yung 1% is the other gases. Okay? So yan. So in summary, so ito yung mga meron tayo. Ito na lahat ng gas laws natin. We have the Boyle's law. It states that the pressure and the volume are inversely proportional. Okay, so when we increase the pressure, the volume decreases, or when you decrease the pressure, the volume increases. The equation is P1 V1 equals P2 V2. Okay, the P1 and the V1 is equal to a constant, P2 and V2 is equal to a constant, and since yan ay constant, we say P1 V1 is equal to P2 V2. For Charles' law, we have the volume-temperature relationship. So it states that the volume and the temperature are directly proportional. So ibig sabihin, pag tumaas yung temperature, tataas yung volume. Pag bumaba yung temperature, bababa yung volume. Example is yung balloon. So, lagay mo yung balloon sa ref, wala lang. Liliit yung balloon. Okay, kasi mababa yung temperature. So, bababa yung volume. Tapos initin mo yan, lalaki yung balloon. Okay? So we have the... Wala yung Gay-Lussac law dito. The Gay-Lussac law, meaning nun yung pressure and temperature ay directly proportional. Okay? So, ibig sabihin ng pag tumaas yung pressure, tataas yung temperature. Pag bumaba yung temperature, bababa yung pressure. Example would be this air can. Okay? Pag pinindot ko to, lalamig. Bakit? Bumaba kasi yung pressure sa loob ng can. Okay, so that is governed by Gay-Lussac law. And then pag pinagsama-sama natin yung tatlo, Boyle's, Charles, and Gay-Lussac, we get the combined gas law. So this is the relationship of all three variables of gases, pressure, volume, and temperature. Okay, so ito daw yung sila. Basically, pinagsama-sama mo lang yung tatlong equations. And we have ideal gas law. Ay, yung ano pa pala, wala dito sa PowerPoint. Yung Avogadro's law, sabi doon that when you increase the number of gas, the volume increases also. So the equation there is V1N1 equals V1 over N1 equals V2 over N2. Okay, so yun yung Avogadro's law. Pag pinagsama-sama natin yung Boyle's, Charles, Gay-Lussac, pati Avogadro's law, we get the ideal gas equation. That is PV equals nRT, where R is the gas constant, which is equal to 0.08206 liter atmosphere per mole Kelvin. And lastly, we have Dalton's law. Sabi nun that the total pressure of the gas is the sum of the partial pressure of each gases, which is usually given. Okay? By the way, kunwari, yung pressure nyo ay iba. No? Ano yung magiging conversions natin? So, turo ko sa inyo yung conversion. For example, gagamit ka ng ideal gas law, yung pressure kailangan naka ATM talaga dito. For others, okay lang kahit hindi sila naka ATM. Pero, for ideal gas equation, the pressure must always be in ATM. Bakit? Kasi yung R natin, naka ATM siya. Okay? So, yan. So, ano yung mga conversions to ATM? So, 1 ATM is equal to 101,325 Pascal. That is also equal to 760 mmHg. And that is also equal to 760 torr. Okay? And also equal to, yan lang. Okay? So, yan yung ating mga conversion. So, 1 ATM equals 101,325 pascals. 1 ATM equals 760 mmHg. 1 ATM equals 760 torr. Okay? Kunwari, example lang, you have 735 mmHg. Convert mo yan to ATM. So, alam nyo na naman mag-convert. 735 mmHg. Then, you use the conversion factor. Nasa baba yung mmHg para makancel. Nasa taas yung ATM. 1 ATM equals 760 mmHg. So, the ATM equivalence of 735 mmHg is 0.97. Okay? So, ganun lang. And just in case lang na lumabas ibang pressure. Yan. So now, tapos na tayo sa gases. Let's talk about others. No? Other form of the state. Other states of matter. No? Pag-usapan natin yung changes of their state. No? Paano uli sila nagbabago-bago ng anyo? So, the reason why nagbabago-bago sila ng anyo is because of the temperature. No? So, kapag tinaasan mo yung temperature, tumataas yung kanilang kinetic energy. Hence, they are more, mas magalaw na sila. Mas mataas na yung kinetic energy nila. And once yung particle natin magalaw, nagjijigal-jigal na sila, lalayo na sila sa isa't isa. Yung instance na lumayo sila sa isa't isa, doon na nangyayari yung phase change. So, kunwari, from solid na magkatabi sila, taasan mo yung temperature, nag-jiggle yan, palayo sa isa't isa. So, pag lumalayo sila onte, liquid. However, kapag malayo na talaga sila, as in yung isa nasa monumento, yung isa nasa MOA, gas na sila. Okay? So, yun yung idea sa change of state. No? This happens when we add or remove energy sa particles natin. Adding energy will cause the particles to move more, hence they will transition from solid to liquid to gas. And that process is involves the absorption of heat, or that is endothermic. Okay, so endothermic to. Endothermic meaning, ito yung spelling endothermic, ibig sabihin, mag-absorb yan ng heat. No? Okay, so yan. So, the melting process will absorb it. So, that is endothermic process. Okay? Bakit kailangan i-absorb yung energy? Kasi, para mapaghiwalay sila. So, from liquid to gas, that's evaporation. That's also endothermic. But kailangan endothermic kasi i-absorb ng particles yung energy para maghiwalay uli sila. And from solid to gas, the transition is called the sublimation. Also, another endothermic reaction. Okay, so para maghiwalay-hiwalay sila. However, yung reverse naman, yun ay exothermic. So hindi yan yung K-pop group. So, exothermic, ibig sabihin yan, release energy or release heat. So, if you want to condense your phases, no, ibig sabihin, from gases, gusto mo maging liquid or solid sila, tawag doon condensed phases, kailangan i-release mo yung energy ng particles natin. So, i-release nila yung energy ng particles natin. So, from gas to liquid, para magdikit-dikit sila, yung ating particles, i-release nila yung energy in the form of heat, no? That's why, di ba, pag napapansin nyo, kapag super maalingasaw, mamaya-maya uulan. Okay? What happens kasi is ganito. Yung gaseous phase natin sa atmosphere, they slowly transition to liquid. Kaya, di ba, sobrang init minsan. Tapos mamaya-maya biglang nagugulat kayo, uy, umuulan na, no? So, dito kasi yun, no? Exothermic yun. As the gas condenses, it releases energy. Kaya umiinit sa paligid. Okay? Kaya yun. So, alam niyo na, ako, ganun yung aking basis eh. Kapag napapansin ko, kunwari, super duper init today, mamaya, uulan yan. Just like last night, no? Last night, I don't know if gising pa kayo, no? Ako kasi nag-ML ako nun. Okay. So, kahapon super init, tas bigla-biglang umulan. Okay. Kasi super init nga, no? So, what happens there is that yung ating particles, they transition kasi. So, until marami na yung liquids, dun na bubuhos yung ulan. Okay. So, yan. So, condensation, that's the transition of gas to liquid. Liquid to solid, that's freezing. And gas to solid, that's called the deposition. Okay. So, yan. Okay. So, yun yung yun yung states of matter. Okay. So, punta na tayo sa last part of our discussion. Second to the last part, rather. Okay, so, let's talk about intermolecular forces and how it affects the phase of matter. Okay? So, ano ba yung intermolecular force? No, actually, dalawa yan. We have the intramolecular force and the intermolecular force. Okay? So, compare natin yung dalawa. Intra, gaya nun sa intramuros, that's a Latin word for inside, no? Intramuros. Intra, Latin, meaning inside. Muros, that is Spanish, meaning wall. Intramuros, within the walls. No? Kaya sabi nga, Manila, that is the city within walls. Kasi literal na may pader. Okay? So, intramuros. So, sa intramolecular forces, ganun din. Intra, meaning sa loob. Molecular, ibig sabihin, molecule. Loob ng molecule. Anong force yung nagdidikit-dikit sa atoms sa isang molecule? Yun yung covalent bonds, no? So, yun yung bonding forces. So, pwedeng metallic bond, ionic bond, and covalent bond yun. Okay? So, yun yung mga intramolecular forces. Again, ano yung ginagawa nila? These are the forces that combines the atoms to create molecules. Intramolecular forces. Pag sinabi namang inter, ibig sabihin, iba't ibang molecules. No? Kunwari, ako, isang molecule ako, tapos yung isang friend ko, isa siyang molecule. Yung connection naming dalawa, intermolecular force yun. Okay? So again, ano yung difference? Kapag intra, within myself, within the molecule. Pag inter, between molecules, from one molecule to another. So is it possible for them to have interactions? Yes. Okay. So ano yung mga examples ng intermolecular forces? We have the dipole-dipole, the hydrogen bonds, and etc. Okay? So pag-usapan natin sila. So again, intermolecular forces, these are forces between molecules, okay? And this is primarily affected by the polarity of the bond, no? Kaya nga diniscuss natin yung polarity. Okay? Because 'di ba sabi natin, when our molecule is polar, we have dipole moment, okay? That means may charges tayo. If you have a dipole molecule and another dipole molecule, pwede silang magkaroon ng interaction. Okay? So, yan. So, ang tawag doon ay dipole-dipole interaction. Again, that is the interaction between two or more polar molecules. One example would be HCl. Okay? So, H is partial positive, Cl is partial negative. Kunwari may nakita yung isang Cl, okay, they will interact with each other. Okay? So, mangyari dan, ito yung HCl na isa, ito yung isang HCl. Okay? So, yung positive ng isang molecule, kakabit sa negative ng isa, ng Cl. And yung Cl, kakabit sa positive ng other molecule. Okay? Bakit sila nagkakabit? Kasi sabi nga natin, positive and negative are attracted to each other. So, therefore, they have dipole interaction. Yung positive attracted sa negatives. Okay? So, that's the dipole-dipole interaction. And also, we have London dispersion forces or London forces. Bakit London? Sa London kasi na-discover to. Okay. So, yan. So, London dispersion forces is present in all molecules. Okay. And this is the only type of intermolecular force between nonpolar molecules. Okay. Ibig sabihin, lahat ng molecule meron nito. Pero kapag ikaw ay nonpolar molecule, ito lang meron ka. Okay. Bakit? Sa London forces kasi, ang nangyayari dito is that yung ating electrons, they play a role here. Diba? Our electrons surrounds the atoms. Okay? However, if nag-bump together itong atoms natin, nag-bump sila, what happens to the electrons? They repel each other. So, since they repel each other, they will create partial charges. Nagkakaroon sila ng instantaneous dipole. Imagine nyo yung tubig, lagay nyo sa plastic, tas itap nyo yun. So, kunwari kayo yung electron, itap nyo yung tubig. Diba nagre-ripple out yung tubig sa plastic? No? Parang ganun din yung logic dito. So, ako yung electron, tas yung plastic bag, yun din yung plastic bag na may tubig, yun din yung electron. Pag nagbungguan kami, magre-ripple yung electrons namin. And as our electrons ripple out, we create instantaneous dipole. Pansamantala lang kami nagkakaroon ng charges. However, kagaya ng nangyayari sa tubig, yung ripple nawawala din. Okay? So the dipole diminishes then. Okay? So again, pag nagbungguan sila, the electrons will ripple out, creating partial charges. So magkakaroon ng instantaneous dipole dito. However, that instantaneous dipole is instantaneous. Ibig sabihin, mabilisan lang. So yung ripples, mawawala din. So balik sila sa nonpolar. Okay? So yun lang yung concept for London forces. Again, dipole-dipole, this is the interaction between polar molecules. Yung polar charges nila, they are attracted to each other. Pag London forces naman, this is the force that is present in everyone. Okay? Kasi lahat ay may electrons. What happens here is that yung ating electrons, when they bounce to each other, pag nagbungkuan sila, the electrons will ripple. And yung ripple effect ng electrons that causes the partial charges, instantaneous dipole. However, katulad ng mga ripples, nawawala din yan. So they will be back to normal shape. Okay, so that's the idea for London forces. For dipole-dipole interaction, may isa pang category yon, hydrogen bonding. So, ang hydrogen bond, we know that this is polar bond. Okay? However, this special form of dipole-dipole interaction is stronger than itself. No? Mas malakas ito kaysa dito. Bakit? Experimentally observed yan. Okay? So, actually, ito rin yung mga mysteries sa universe. No? Because our existence sa mundo ay dahil dito sa hydrogen bonds. Kasi without hydrogen bonds, most likely yung water sa Earth nag-evaporate na yan dati pa. Remember, before the modern ages, yung ating mundo is a molten molten material lang siya. No? So, kasi galing tayo sa star, di ba? Sa sun. Then, nagkaroon tayo ng planetary nebula. Then, naging planets tayo. Before, yung Earth ay isang hot rock lang siya. Literal na mainit, no? Pero, yun nga, dumating yung asteroid na may tubig. So, nagkatubig sa Earth, no? Imagine nyo, if walang hydrogen bond, edi wala talagang tubig sa Earth, no? Nag-evaporate na agad yon sa init ng Earth. So, ibig sabihin, hindi na tayo nag-exist ngayon. However, we exist because of the hydrogen bond. No? So, this is still a mystery. No? Bakit mas malakas to compared to other dipole-dipole interactions? No? Pero yun na nga, experimentally, siya yung mas malakas. So, this is only present if you have HF, NH, and OH bond. Okay? So if you have these types of bond, HF, NH, and OH bond, silang tatlo lang yung nagpo-form ng hydrogen bond. Okay? So saan natin ito makikita? Sa ating DNA. Okay? Bakit? Gusto niyo makita? Pakita natin. Google. Pakita ko sa inyo yung nucleotide bases natin. Okay? So, ayan. So, this is our nucleotide base. Yung Chargaff's rule. Sa biochem na yan. Okay? So, this is our nucleotide bases. So, we have the ACTG kapag yan ay DNA and AUCG kapag RNA. Okay? So, bakit sa tingin nyo naka-strand yung ating DNA? Ang sagot doon ay hydrogen bond. Kaya nga sabi ko sa inyo, yung hydrogen bond, that is the mystery that allowed our existence sa Earth. No? Okay? So, yun, yung AT, bonded yan together by hydrogen bond. As you can see, you have OH-NH bond here. So, hydrogen bonding yan. Yung GC and, yung GC pair natin, they are also bonded sa hydrogen bond. May makikita kang NH-OH bonds dyan in between the two. So that's the reason why our DNA is double-stranded, no? Magkadikit silang dalawa. Okay? Because of hydrogen bonding. Okay? And without hydrogen bonding, we are dead. Okay? Tagal na tayong dead. Kasi mainit sa Earth dati. So that's why hydrogen bond is very important. Okay. So ayan, again, this hydrogen bond, this is a special form of dipole-dipole. And it only exists if you have HF, NH, and OH bond. Anything else ay either dipole or London. Okay. So ayan. So yun lang. So on this table naman, pinapakita yung density ng water. Okay. So pinapakita na dito yung changes sa density ng water. Okay, so si water, this is a very small molecule. However, its density is very high. Bakit? Because of hydrogen bonding. No? So si water lang yung 18 grams per mole na molecule, pero ang laki-laki ng density niya, no? 1 gram per ml at exactly 4 degrees Celsius. However, the density changes at different temperature scale because of yung heat energy, no. Pag mas mataas yung heat energy, the molecules expand. So that means the density changes, no. So yun yung reason bakit pag tumataas yung temperature, bumababa yung density. Kasi gumagalaw-galaw na yung molecules. Ito naman yung trend dito na pababa. Bakit? Kasi nangyayari, kapag yung ating water, nagpo-form siya ng solid, nagre-rearrangement siya, no? So, para silang mga dancer, diba? Kunwari, magbo-form sila ng solid, mag-special arrangement sila, no? So, yung special arrangement ng water, that expands, no? That uses more volume. Kaya nga napapansin nyo, pag naglagay kayo ng tubig sa freezer, lumalaki yung tubig, di ba? Kunwari, nilagay nyo yung soft drinks sa freezer. Ano nangyayari? Lumulobo yung bote. Bakit? Kasi what happens is that kapag magki-crystallize yung solid natin to form the ice, nagre-rearrange siya. The rearrangements consume bigger volumes na. Pag nag-rearrange yung atoms mo, lalaki lalo yung buong volume. So that's why lumulobo yung ating containers. No? Kaya kapag kayo maglalagay kayo ng tubig sa freezer, please wag nyo punuin. Okay? At least lagyan nyo ng gap sa taas. No? Kaya nga napapansin yung mga bote na tinitinda sa 7-Eleven, Alphamart, no? Minimart, no? Hindi siya fully, hindi siya kompleto until sa taas. May gap. Kasi, yun nga, kapag furnace mo yun, mag-expand yung liquid. Okay? Kasi mag-rearrange yung water molecules. Okay? And ito yung mga, ito yung reason bakit nababasag yung lalagyanan ko ng tubig dati. Okay? Kasi hindi ko pa alam tong topic na to. Bata pa ako nun. So, may lalagyan ng tubig, nasisira siya dahil dito. Okay? So, dahil sa expansion ng water kapag umiinit or kapag lumalamig. Okay? And yung water, it possesses hydrogen bonds. Ayan. So, yung OH bond doon, it interacts with other OH bonds. Okay? And now, let's talk about the last part. Last part na to. Second to the last part pa pala. Sorry. Okay lang. Kwento-kwento na lang naman to. Okay, so let's talk about liquids, no? So, in liquids natin, ayun. So, ano meron sa liquids? Usually, ang liquids natin, they are composed of hydrogen bonding o kaya dipole-dipoles, no? For example, yung water, yung muriatic acid, no? So, yung mga solutions na yon, they are composed of dipole or hydrogen bonding molecules, no? So, sila yung mga liquids. Okay? So ngayon, ang nangyayari sa atin is yung ating liquid, we know, nagbo-boil yan. Okay. So nagbo-boil yan because of its vapor pressure. Okay. So ano yung vapor pressure? That is the pressure exerted by the liquid against the atmosphere. No? Okay. So yun. So kapag ang ating vapor pressure ay equal sa atmospheric pressure, then our water will start to boil off. No? Okay. So yun lang idea dyan. Paano natin mababago yung vapor pressure? Pwede, taasan mo yung temperature. As you can see here, if you increase the temperature, the vapor pressure also increases. That's why, ang nangyayari sa ating tubig ay kumukulo siya at higher temperature. Okay. And once na nakamatch niya yung vapor pressure sa paligid, yung atmospheric pressure, once equal na sila, doon na mag-start mag-evaporate yung ating liquid. Okay. So, yun. Another factor na pwede magpabago sa vapor pressure is yung altitude. No? So, wala, punta kang Baguio, mas mabilis kukulo tubig doon kaysa sa Manila. Kaya punta ka Mount Everest, mas mabilis nang kukulo tubig doon kaysa sa Manila. Bakit? Kasi at higher temperature, the vapor pressure, the atmospheric pressure is lower. Mas mababa na yung atmospheric pressure. So, ibig sabihin nun, onting urong na lang sa temperature, yung vapor pressure ay equal sa atmospheric pressure. Okay? So again, for our liquids to boil, the vapor pressure of liquid must be equal to the atmospheric pressure. Okay? So, binabago natin yon by changing the temperature o kaya lumipat tayo ng ibang lugar para mas mabilis kumulo yung liquids. Okay? So yun. So boiling is a process where our liquids are converted to gas, and the boiling point is the temperature at which your vapor pressure is equal to the atmospheric pressure. Okay, so ito na pala yung sinasabi ko. So here are some conditions that affect the boiling point. Yung altitude nga, no? Altitude, the higher the altitude, the lower the atmospheric pressure is. That means the lower the boiling point of the liquid will be. Okay. So, yun. Okay, so here are some properties of liquid na na-experience natin in daily life. So, we have the surface tension, and later on, we will discuss viscosity. So, what is the surface tension? The surface tension is the displacement of water in order to maximize the intermolecular forces of attraction. Okay. So, yun yung expansion or yung pag-move ng water molecules in order to maximize the intermolecular force. One application of the surface tension would be the capillary action. This is a phenomena in which yung liquid ay umaakyat or bumababa sa tube, no? So, capillary action is the process where yung liquids ay umaakyat or bumababa ng tube. So cohesion, ito yung process wherein yung ating water ay aakyat sa tube. Adhesion yan. Adhesion pala, sorry. So yung adhesion, ito yung process wherein yung water natin ay aakyat sa tube. And yung cohesion, yun yung process wherein yung liquids ay bababa sa tube. No? So yan. So this is one example. If you place liquid, lagyan mo yan ng capillary tube. Ang capillary tube ay parang straw lang. Mapansin nyo, di ba sa straw, yung liquid sa loob ng straw mas mataas kaysa sa paligid, no? Because of the adhesion. Okay, in order to maximize the intermolecular forces, especially the hydrogen bonding, aakyat sila. However, there are some cases na hindi ganun nangyayari. That happens when your cohesion forces is greater than the adhesion. Example, yung mercury metal. Ano yung meron sa mercury metal? Sa lumang thermometer, mapansin mo yung dulo nun ay curved na pag ganito. Ganito yung curve niya. That is because of the cohesion. Ayaw niya kasi kumabit sa glass. No? Kaya gumaganon siya. Nagbabulge outward siya. Okay. And kapag gusto naman niya yung glass, for example, yung liquids, they form the concave meniscus. Okay. So pag nakakita ka ng concave meniscus, most likely yun ay adhesion forces. Pag convex meniscus, yun ay ito ay adhesion, ito ay cohesion. Okay? So yan, tingin lang kayong thermometer. Pag nakita nyo yung thermometer nyo, ganito yung itsura ng meniscus, convex. Ibig sabihin nun, mercury yon. Delikado yon, ingatan nyo yon. Pero kapag nakita nyo yung thermometer nyo, ganito yung itsura sa taas. Okay, naka-concave siya. Ibig sabihin, alcohol lang yun nandun sa loob. So safe yon. Dati kasi may mercury thermometer kami and nabasag yun. Pero bata pa ako nun, maybe around 3 years old. Pero naalala ko yun eh. So yung tinitignan ko dati yung mercury namin, mercury thermometer. Nakaganito yung shape niya talaga. Okay? So yun. Imagine 3 years old ako, di ko alam na toxic pala yung mercury na. Pero di ko naman hinawakan. Pero na-amaze lang ako kasi nakaganon siya. Tapos nag-chem ako. Tapos yan, doon ko nalaman ganun pala. So yun yung reason bakit siya na convex meniscus. Kasi malakas yung cohesion forces kapag metals. Kapag liquids, mas gusto nila yung adhesive forces. Kaya sila na convex meniscus. Okay? So ito yung surface tension, capillary action. So suppose you have liquids, mapapansin nyo dito sa tube, umaakyat yung liquids, no? Because of the adhesive forces. When you say viscosity naman, it refers to lapot, no? Basically, yung pagkalapot, no? May mga liquids na hindi malapot, meron namang sobrang lapot. Bakit? The viscosity of the liquids are affected by the intermolecular forces of attraction. Imagine nyo yung IMFA, yung intermolecular forces, as clinginess ng ating molecules. Kung sila is super clingy, ibig sabihin, mahirap sila mag-move. Okay? Mahirap sila gumalaw. Pero kapag sila ay hindi clingy, ibig sabihin, madali sila gumalaw. Mabilis sila mag-separate. Okay? So, ganun din dito sa liquids. No? When our liquids have higher forces of attraction, ibig sabihin nun, mas viscous sila, mas malapot sila. Compared to liquids that have lower intermolecular forces, ibig sabihin nun, hindi sila malapot. No? Okay, so here are some examples. Ito na lang, gawa na lang example dito. So medyo hindi tayo, medyo hindi kayo familiar with some here, no? Pero ito na lang, gawin ko example. Suppose water and glucose. So draw ko yung molecule. Sino yung mas malapot sa dalawang to? Hulaan nyo. Sino mas malapot? Yung tubig o yung asukal? Pagbasa, no? Pag liquid. Sagot ay yung glucose. Mas malapot yung asukal kaysa sa tubig. Bakit? Kasi, mas marami siyang intermolecular forces. Anong intermolecular force kaya nila gawin? Kaya nila mag-hydrogen bonding. Okay? So, for water, dalawang H bond yan. For glucose, ilan? Isa, dalawa, tatlo, apat, lima. Limang H bond meron siya. So, since mas marami siyang hydrogen bonding, that means mas malapot yung glucose kaysa sa water. Ibig sabihin, mas clingy sila. Mas maraming kabit-kabit sila. Okay? So, that's why glucose is much viscous than water. Okay? So, ganun din yung ibang mga household liquids natin. For example, yung honey, no? Napansin niyo yung honey, di ba? Ang bagal-bagal mag-flow. Dahil yon sa glucose sa honey, no? Maraming hydrogen bonds doon. Okay? So, the next time na bibili kayo ng honey, o kaya may honey sa bahay niyo, pasikat kayo, sabihin niyo, ay, alam mo ba, malapot yan dahil sa hydrogen bonds. So, di ba? Sulit yung tuition. Okay? Alam niyo, dagdagan pa kayo ng baon, di ba? So, yun lang yung reason, no? Bakit may mga liquids na malapot and bakit may mga liquids na umaakyat sa tube. Okay? So, umaakyat yung liquid sa tube because of adhesive forces due to surface tension in order to maximize the intermolecular forces. Yung lapot naman, this tells us about the extent of the intermolecular forces. Kapag mas maraming IMFA, ibig sabihin, mas malapot. Pag onti lang yung intermolecular forces, ibig sabihin, hindi malapot. Okay? Yan. So, yun lang. And lastly, solids. Patapos na tayo sana. Tignan ko ilang slides na lang. Onting slides na lang. 4 na lang. So, lastly, solids. Yung ating solids, it can be characterized into two. We have crystalline and amorphous solid. Pag sinabing crystalline, ito yung mga matitibay na solids. No? Ano example niyan? Yung Corning Gorilla Glass sa ating cellphones, sa mga bagong iPhone, and sa mga watches, sa mga quartz. No? So, yun yung mga crystalline solid. They are strong. Yung amorphous solids naman, ito naman yung mga marurupok. No? Parang friends natin. So, sila yung marurupok. No? Example niyan would be chalk. Okay? Ano pa? Baby powder, makeup nyo, no? So, yun. Solids yun, pero bilis masira, di ba? Because they are amorphous solids. The question is why? No? Bakit may mga solid na matibay? Bakit may mga solid na marupok or mabilis masira? The answer has something to do with the crystalline structure. Yung structure ng atoms natin. So, ito kasi yung itsura nila. Yung atoms natin, they crystallize. No? They have structures kapag sila inabuo. So, for crystalline solid, yan ay maganda yung arrangement. No? Maganda yung arrangement ng ating solids. Pero kapag yan ay amorphous, gulo-gulo na. Gulo-gulo-gulo. Okay? So, walang pattern yung arrangement ng particles natin. That's why, for amorphous solids, mabilis sila masira. No? Example, makeup. No? Pag zoom in mo yung atoms doon, kalat-kalat sila. Unlike for crystalline solids, maganda yung arrangement. So, matibay sila. And this is also one reason why water, pag yan ay naging ice, di ba, ang tibay-tibay? Minsan nga may mga yelo na ihampas mo sa pader, mukhang yung pader pa masisira, di ba? Sobrang tibay. Yun yung reason bakit ganon. Ito, kasi yung water, kapag sila ay namuo, they form crystalline solids. Yeah, it seems like ilang hampas mo na sa yelo, hindi pa rin siya nasisira. Crystalline solid kasi siya. Okay. Compare that with the baby powder, milku, okay? Yung mga powder, makeup, no? Mabilis sila masira. Onting pindot mo lang, sira na. Okay? Yun yung difference nila. Again, crystalline, ordered yung arrangement. Pag amorphous, hindi ordered yung arrangement. Okay? So, yan. Yung glass. So, yung tibay ng glass, depende sa arrangement ng molecules. Pwedeng amorphous yan. Pwedeng crystalline. Okay. So, kaya mapapansin nyo, di ba, sa YouTube, ewan ko, nanonood kayo nun, pero ako ay fan ng how it's made sa YouTube. Pag wala akong ginagawa, nakatulala lang ako doon. bukod sa panonood ng Friends. Okay. So, katulala ako dun sa how it's made. Pinapakita dun kung paano ginagawa yung mga glass, no? Tapos, bakit sila matibay? So, ang ginagawa nila, in order to strengthen the materials, yung mainit na glass, ilulublob nila sa malamig na tubig. No? And that will force the molecules to suddenly arrange in patterns. Pag nilublob mo yan sa tubig, biglang a-arrange yung molecules. No? Kaya matitibay yung ibang glass. However, yung ibang glasses, hindi ganun yung process. Kaya mabilis silang masira. Okay? Okay, so ito yung ibang examples ng ibang example ng glasses. Okay? So that will be all for chapter 5. Okay, so tapos na tayo sa chapter 5. We were able to cover the idea of kinetic molecular theory. It just says that yung particle natin, when heated, tumataas yung kinetic energy. And the increase in kinetic energy causes the particles to move apart. No? And when they move apart, they transition from solid to liquid and later on to gas. No? Kapag binabaan mo naman yung energy, bumabagal yung particles and that causes them to come together. So from gases, magiging liquids, then later on, magiging solids. Yun yung reason bakit meron tayong iba't ibang phases of matter. Okay? So for gases, they can be characterized, no? Yung kanilang physical properties, they can be characterized by gas laws, no? So gas laws, marami yan. We have the Boyle's law, pressure volume, the Charles law, volume temperature, Gay-Lussac, pressure temperature, and Avogadro's law, volume moles. And then pag pinagsama-sama yon, you get the combined gas laws, PVT on, and the ideal gas law, PVNRT, where R is the gas constant at 0.08206 liter atmosphere per mole Kelvin. Okay? And then for liquids, okay, so yung liquids, yan, may dalawang phenomena yon. Pwedeng siya mag-cause ng surface tension, pwede rin naman siya maging mag-cause ng viscosity. Bakit ganon? Because of the intermolecular forces. No? So tatlo yung uri ng intermolecular forces natin. We have this hydrogen bonding, which is the strongest of all and only exists when you have NH, FH, and OH bond. You have the dipole-dipole, which occurs in all polar bonds. And then you have the London forces, which exists in all molecules. Okay? So, yung London forces, lahat ng molecule meron nun. Okay? And that is the weakest interaction. Okay? So, yun. So, in liquid, yung pagiging viscous nila, that can be affected by IMFA, the intermolecular forces of attraction. So the stronger the IMFA, the more viscous it is. Okay? So yun. And the lower the IMFA, the less viscous it is. No? So yun. For example, gasolina, pati mantika. No? So yun. Yung mantika kasi, although walang polar molecules doon, ang daming atoms doon. So around 20 plus atoms. However, yung gasolina, iilan lang. No? Around 10 atoms lang. So yung 20 atoms and 10 atoms, yung difference na yon that causes big changes sa sa properties ng matter. Okay, so yung mantika, malapot kasi ang daming atoms. However, yung gasolina hindi masyadong malapot kasi onti lang atoms doon. Okay? So yun. And for solids, again, there are two types of solids, crystalline and amorphous. Crystalline, sila yung ordered patterns. So ito sila, ordered yung patterns. That's why matibay sila. Example would be yung yellow. O kaya yung quartz. O kaya yung nasa cellphone natin. Hindi agad nasisira yan unless ibalibag mo talaga. So yung aking phone, hindi siya nababasag yung harap. Recently lang nabasag yung harap. Kasi masyadong mataas na yung pinaghulugan niya. No? Ayan. So yan. Pero di ba normally hindi naman siya agad-agad nababasag. Kasi nga, crystalline solid yon. Pero kapag yan ay amorphous glass, yan yung mabilis masira. No? Okay. For example, yung baso natin. Di ba yung baso pag naguhugas ka, onting galaw lang, sira agad. Di ba? Ayan. Amorphous kasi yun eh. Amorphous solid yan. Kaya yung mga powders nyo, baby powder, mail ko. So, yan. So, sila yung mga amorphous. Okay? So, that will be all for the entire midterm. Again, yun na yun. So, tapos na tayo sa midterm period. That means by Friday, hindi ko na kayo imimit so that you will have more time to review for your lecture and lab exam. No? Pero ako, I want you to focus on the lecture. Kasi sa akin naman, wala naman kayong problema masyado. Okay naman yung grades niyo sa akin. So, okay yan. No? Good tayo dyan. In ano naman, sa usapang worksheets, nasabi ko na sa inyo yung mga pointers kanina. Panoorin nyo na lang uli later. And then, mataas naman ako magbigay ng score kapag mga worksheet. No? Kaya don't worry. Most likely makakakuha kayong perfect sa akin. Unless may mali talaga. No? So, yun. Okay. And also, yun nga, yung inyong lecture, that's 100 items. Take note, items, hindi points, items. Okay. So, good luck with that. I want you to focus on that more. Kasi sa laboratory, ano lang tayo 50 items lang. Okay, so kayang-kaya. So, yan. I hope na maging enough yung time na ibibigay ko sa inyo sa Friday. Hindi na tayo magkikita nun para makapag-review kayo. And also, mag-open ako ng quiz for Chapter 4 and Chapter 5 this week. No? So, yung Chapter 4 quiz, open ko siya bukas. And yung Chapter 5 quiz, itong diniscuss ko, maybe around weekends na para makapag-take kayo. Question, ilang time limit sa lecture? According to the cluster head, no? Sa analytical chem kasi ako cluster head. Sa in-org, hindi ako yung head dito. Kaya, sumusunod lang ako. so dito sa dito sa subject natin na ito, yung time ng exam ay depende sa prof, no? Okay. So, I don't know kung ilang minutes ang ibibigay sa inyo ni Ma'am Cruz, no? Okay, si Ma'am Kath, 'di ba? Okay, si Ma'am Casey. So, di ko alam kung ilang minutes bibigay niya sa inyo. Pero, para sa akin, sa laboratory, maybe I'll give you around 1.5 hour, no? Sagad na 'yon. So, siguro ganun kahaba yung bibigay kong time. Pero for the lecture, you ask, ano na lang, si teacher nyo kung ilan minutes. Kasi nagugulat ako na, na nakita ko yung copy ng exam nyo. Sabi ko, nako po. Gaganon talaga. Good luck na nan sa inyo. Kaya sinabi ko, kailangan matapos tayo today para makapag-review kayo ng matindi. Okay. So, ganun ha. I wish you all the best na lang sa lectures. Sa lecture exam. When po midterms? Next week na po. No? Starting Monday until Saturday. Yun yung midterm exam. Pero yun nga, 1 week yung allowance. So, kayo bahala kung kailan nyo iti-take. Okay. So, pwedeng i-take nyo siya sa Monday agad. Pwede rin naman sa Friday. No? Kayo bahala. Depends on your most available time. Okay, so again, midterm exam by Monday. Punta tayong calendar. So ito, calendar tayo. Calendar. Ito para guided na rin kayo, ha? Okay, so this is the calendar. So we are on the time, first week of March. Ito tayo, Tuesday. So last discussion natin, Friday, free time nyo na yan. So ito, March 15 to 20, ito yung official anniversary ng ating lockdown. Ito yung midterm nyo rin. Okay. So midterm yan. Midterm exam dito. Then by next week, dito na lang ulit tayo magkikita for the grade consultation. Papakita ko sa inyo yung grades nyo. Okay. So again, reminder lang, no? So yung quiz 4 and quiz 5, ibibigay ko siya starting tomorrow until the weekends. No? So ayan. So yun yung quiz 4, quiz 5, and also yung exam starting 15 yan until 20. Okay? So anytime, pwede nyo siya i-take at your most convenient hour na lang. Okay? And also, yung mga worksheets natin, yung deadline niya ay next week din. Siyempre, hindi ko isasagad sa Sabado. Mag-check pa ako ng new worksheets niyo. So, maybe around Wednesday, yun na yung final deadline natin. So, set up ko na lang yung submission box. Let others know that March 17, ito yung final deadline ng lahat ng lab worksheets natin. Again, for Chapter 5, mayroon kayong lab worksheet doon. Okay? So, ang sasagutan nyo ay yung guide questions lang. Okay? So, dito lang tayo. Ay, ba't anakim? Ibang subject pala yan. So, ito. For Chapter 5, ito lang sasagutan nyo yung experiment 5 datasheet. Then, upload nyo na lang dito. Okay. So, ito yung wag nyo na sagutan to kasi wala tayong experiment. Okay, and hindi available lahat ng chemicals sa bahay. Okay, kaya ito na lang, yung guide questions na lang. Please answer the essay part, mga 2 to 5 sentence. Wag na kayo nobela. Okay. Kasi basta nasabi nyo naman yung gusto ko mabasa. Full points na yan. 5 points agad yun or 1 point. Okay? So, ganun. Guide questions lang sasagutan nyo dyan. Okay? Again, sa quiz 4, remind ko na lang din. So, yung sa datasheet natin, remind ko ulit, no? Although sinabi ko na kanina, para sure na talaga tayo. Diba sa quiz 4, may nakalagay dito, sabi dito sa part 2, gamitin daw yung link sa baba, no? To answer this problem. However, since this link doesn't work anymore, we have to use the activity series na lang. So, activity series, andito yon CO4B. Ay, hindi, CO4A pala, sorry. So, andyan yung activity series. Sabi ko sa inyo kanina. Lang. Saan ba yun? Okay, so ito yung activity series, no? Ano yung makukuha nating idea dito? Kapag yung metal mas mataas kaysa doon sa i-react mo, may production of gases doon. For example, yung hydrogen, react mo with zinc, magpo-form yun ng hydrogen gas. Magbabubbles yun. However, yung hydrogen i-react mo with, let's say, gold, walang reaction. No? Walang magbabubbles doon. Okay. So it tells us na yung mga nasa taas, they are more reactive than those who are in the bottom. So if you are asked to characterize them, if you are asked to arrange them accordingly, just look at the table. Kung sino nasa taas, yun yung highest yung reactivity. Kung sino yung nasa baba, yun yung lowest yung reactivity. So ganun na lang gagawin nyo dito. So when you arrange this 4 metals, this 4, and this 4, use this table na lang. Okay. Hanapin nyo dyan, sino yung highest? O yun yung una. Sino yung lowest? O yun yung nasa dulo. Okay? Yung table dito, hindi na natin ma-fill out to kasi hindi na gumagana yung link. Yung link kasi maganda to dati. Pero ngayon hindi na siya maganda kasi tignan nyo. Wala na siya. Okay. Yung quiz 4 that will be open starting tomorrow until 3 days kasi yung quiz natin So day 1, maybe around until Saturday. No? Tapos yung quiz 5, i-open ko siya around Saturday and it will run until next week. Good for 3 days lang din. May video, sir, dun ko bines. Meron ba? Sige. Pwede naman. Sa YouTube na. Okay. So, pwede search nyo yung reaction ng metal na to with the other. Pwede rin yun. Although, that will consume more time. Okay. Sa module. Ito. Nga pala. Kalimutan ka. Ito yung video. Sige. So, yun na lang ha. And for module 3, yung chapter 3 natin, again, sa lab experiment, buksan ko tong guide question natin dito. for ano, 'di ba bond length yung problem ninyo last time? So sabi ko sa inyo, yung correction natin, yung bond length, i-add nyo lang yung covalent radius. Yung covalent radius dito yung makuha sa CO3b. Okay. So kunin nyo na lang dito. Hintayin lang natin mag-load. Teka lang ha, nahanap ko yung ano. Saan kaya yun? Okay. So ito. So to determine the bond length, kung andito naman siya sa table. Okay. So ito, kung nandito sa table yung inyong bond length, ito na yung kunin nyo. However, kung wala dyan yung bond nyo, ipag-add nyo na lang yung covalent radius ng dalawang atom. Okay? So ganun na lang gawin nyo for this. Okay? Yun lang yung mga ano natin. Again, all the experiment worksheets, they will be accepted until March 17 only para makumpleto ko na yung checking niya. Okay, so yun. Yung quiz 4, ang coverage niya ay yung stoic. Okay, yung reaction, balancing, and then later on yung stoic, yung mass-mole relationship. Yung video na sinend ko sa inyo, nagka-emergency ako last time kaya nag-asynchronous ako doon. So, andito sa chat box natin yung link ng video. Panoorin nyo na lang yung sa stoic. Okay? And then, for quiz 5, itong chapter na diniscuss ko, yung gas laws, kinetic molecular theory, yung solids, liquids, intermolecular forces. Puro terms lang naman. No? Ang may calculation nandito yung gas laws. Okay? So, yun yung coverage ng quiz 4 and quiz 5. Okay, so yun. Again, for quiz 4, yun ay balancing and stoichiometry. Yung video ng stoichiometry, yan, kinoment ko na dito. So, hopefully, napanood nyo na yan. No? Kasi nagka-emergency ako that time. Kaya I have to do asynchronous class. Then, yung discussion natin today, lahat ng diniscuss ko today, yun yung para sa quiz 5. No? That will be open starting Saturday and it will run until the next week. No? So, yan. May mga questions kaya? Sige, okay lang. Sir, may mga mall AOL tal pa po ba? Merong mall AOL tal. Okay? Kasi, ano, di ba nung I don't know kung kailan lumabas yung survey na yun sa inyo this sem, no? Pero alam ko nung enrollment kayo, may question ata na ganun sa inyo, no? Pero yung for tal kasi, total analog learners, ang ginawa dito is by consultation pa if tatanggapin kayo sa TAL. No? Kasi yung TAL, that will only work for students talaga na no access talaga sa internet. No? Very limited access to the internet. And may requirement kasi for TAL, kailangan yung student, kaya niya talaga mag-work independently. Okay? Kaya medyo naging selective na yung pagpili sa analog learners. Pero for AOL, MOL, meron pa rin naman. Okay? So, sa inyong class, mostly ay AOL. Kaya, onti lang talaga tayo every session. So, mostly AOL sa inyo. Ibig sabihin nun, it doesn't necessarily mean na kailangan nyo umattend ng video conferences natin. As long as you watch the recordings ng lesson and you can comply sa ating assessments on a given schedule. Ako naman, maluwag naman ako between AOL and MOL. No? Hindi naman tayo nag-check ng attendance and hopefully walang nag-check ng attendance talaga sa inyo kasi that's not advised. No? Okay. Kasi yun nga, you can shift the learning modality. Okay, kasi to be honest, iba-iba naman yung internet connectivity natin. No? Minsan meron, minsan wala. Kaya yun, dapat walang nag-check ng attendance. Okay, so yun yung mga TAL, meron pa rin pero onti lang sila. Pili lang yung mga nagtatal, no? Kasi medyo kailangan kaya talaga ng student yung independent dependent learning para hindi siya bumagsak. Okay? Pero for AOL, MOL, yun, sa klase nyo maraming AOL, kaya onti lang tayo parate. Okay. Basta ang requirement lang, basta makatake ka ng assessment and makapagpasa ka ng mga requirements, yun. You will get a grade. Okay. So any more questions from the class? No? Kasi I assume na magiging busy na talaga kayo by the weekends. Kasi midterm exam na next week na. Kaya kung may questions kayo, don't hesitate to message me ha. Okay. I-announce ko naman sa class if that is a major question. No? Question na kailangan lahat makaalam. Okay. So, ganun lang. And I hope na ayun, masagutan nyo lahat ng mga questions, no? Especially sa lecture. Ang dami dun eh. So, prepare very well for your examination. If you want to study, kunwari, di gumagana yung mga video links sa inyo. So, just go to YouTube. Punta kayo sa ating channel. Hanapin nyo lang yung MTY1108. No? Lahat ng MTY1108 andito. Okay. So, hanapin nyo lang MTY1108 starting chapter 1. Yung orientation, sinave ko pa yun, alam ko eh. So, ito yung orientation natin, 30 minutes lang. 30 plus minutes. Okay. So, starting orientation, ina-upload ko yan until the end of the semester so that makapag-bawi kayo, no? Okay. Ang ginagawa ng students ko sa medtech, no? Kapag exam na namin or pag quiz, sila binge watch, no? As in, pinapanood daw talaga nila uli lahat yan. Okay. Para makasagot sila. Okay. So, kayo rin, pwede nyo rin gawin yun. Okay. So, basta ang idea lang is makapasa kayo for our exams. Okay. So, with that being said, no, nasabi ko naman kailangan ko i-announce. So, I wish you all the best. And hopefully, by the next time na magkita tayo for the grade consultation, matataas yung grades natin. Okay. Basta yung lang ha, yung lab experiments, pakipasa sila lahat by March 17. Okay? So, yun yung final deadline natin. Okay. Ayoko magbigay ng deadline this weekend for the lab worksheets para makapag-review kayo na maigi. Okay? So, good luck. And do you have any questions pa or we're good to go na? Okay. So, I assume okay na tayo, no? Basta if you have any questions, don't hesitate to message me, no? I will reply kapag free ako, no? So, yun. Kahit madaling araw, mag-message kayo, okay lang, basta gising pa ako, no? So, yun. So, I'll see you again next week. So, hopefully, mataas yung mga grades natin, okay? So, yun. A copy of the class recording will be uploaded on YouTube. And with that, so thank you. And